Hi everybody, welcome to our next short guide about how to make the most out of NExTNet. Today, I want to show you some of the ways that NExTNet can help drug discovery by letting you, the scientist, get the big picture. Let's get started. So, we all know that treating illness is complex, and drugs and therapies have also dramatically increased in complexity to tackle these problems. Cell therapies, gene editing, immunotherapies, and others have recently been highlighted for their significant potentials. Still, cures and treatments are no easy task, and any early therapy has uncertain results. And while drugs or therapies are getting better every day, there's still one major complicating factor. Treatment doesn't happen in a vacuum. Oftentimes, patients are being treated with other therapies or medications, whether as part of combination therapies or potentially to mitigate side effects. These medications could be given before, concurrently, or after your drug during treatment. But it's not that simple either. It's not enough to know that other drugs are being used to treat the disease you're interested in. You also want to know the biological details and genetic mechanisms. That includes interactions at the DNA, RNA, and protein levels, among others. To make things even more complicated, those proteins often interact with each other, and genes are impacted by multiple drugs, and often in differing ways. When you're just starting out and unfamiliar with the research landscape, these relationships can be hidden. Finding evidence and relevance through multiple degrees of separation is hard to do manually, but a strength of NExTNet. So, let's take a look at an example that recently came up with a customer. ADAR is a gene which in humans encodes a protein involved in RNA editing through site-specific deamination. This technology has attracted interest lately for many reasons, including its potential to treat many different diseases. So if we search for ADAR in NExTNet, this knowledge graph can be a great place to start exploring its complexities. Let me just organize the graph a bit. If you've seen our other demos on our website, you'll be familiar with the graph representation of data. If not, feel free to check them out or explore our expanding documentation library on our website. There we go. If I click on the literature node for ADAR, the detail box shows a list of edges and scientific connections. Now, each of these edges represents a specific scientific relationship extracted from published scientific papers. So this is even better than a regular reading list. In the very near future, we're going to be implementing natural language search and summaries as well as integration into word processors and existing presentation programs. We want to make exploring a new subject with NExTNet as seamless as possible. But in the meantime, feel free to look at our other demo to get a better understanding of the literature nodes in detail. Getting back to our use case, ADAR has also emerged as a potential treatment for ALS, or Lou Gehrig's disease. RNA editing failures have been suggested as a mechanism behind some variants of the disease. To get a better understanding, however, let's add ALS to our search queries and see what comes up. Okay, here we go. Let's organize the graph a bit. We're also just about to launch filtering, so you can limit results to specific node types, so keep an eye out for that. When looking at complex graphs, it can often help to rearrange the graph into the hierarchical view. To do so, simply right-click on the node you want to be the root of your hierarchy, and you'll see the results. If you want to switch it back, simply right-click anywhere outside the graph to go back to the conventional view. Now, while the graph has literature nodes for ADAR, it also has important molecular data that I'm more interested in. Let me just tease it apart. I want to go take a look at the actual genetic mechanisms. We see that ADAR is connected to a gene called SOD1, or superoxide dismutase 1. If we click on it, there's some basic information detailed, but NExTNet already has direct links out to open source databases. You might be able to find data here that you're interested in. Also, if your research group is interested in incorporating your own proprietary data into NExTNet, we can do that too. That way, you can have links to internal databases in a secure manner without exposing your data to the outside world. Please contact our sales team if you're interested. Now let's go back to NExTNet. So, if I were developing an ADAR-based therapy to treat ALS, I might be interested in potential interactions with other treatments in the clinic right now. Specifically, the drug riluzole is one of the few FDA treatments approved for ALS. I'm interested in finding out how riluzole might interact with ADAR, so let's replace ALS with riluzole. Since riluzole is an ALS drug, the connection is implied, and I want to focus on the interactions between the drug and the gene. Here we go. Let me spread things out a bit. Once again, There's a literature node here about riluzole that I can click on and see its edges. If I want to get a better understanding of the drug, this is a good place to start. But I'm more interested in the molecular connections and interactions. Let me pull apart these nodes. Immediately, I can start to see connections between riluzole and ADAR with multiple degrees of separation. SOD1 is reflected here, just like before, but we can also see intermediary pathways. NExTNet has also surfaced other genes that have pathways in common and which I didn't know about beforehand. For example, here is KCNH2. I don't know what this gene does, but apparently it has pathways in common with ADAR and is affected by riluzole. If I click on the node, there's a bit of a summary, but let's just add it to our query. That's the best way to get a sense of the big picture. And there we go, here's our new graph. This new graph has updated literature, protein, DNA, drug, and pathway nodes. These reflect the interconnections among ADAR, riluzole, and KCNH2. But first, let me just tease these literature nodes apart. I also want to mention that oftentimes these edge details in literature nodes can offer insights into other genes or proteins that I might want to look at. We're continuously incorporating a broad range of literature, and it's been very helpful to our adopters. But let's get back to trying to understand the more complex relationships that are at play here. I see that there are 3 pathways that NExTNet has identified are common to ADAR and KCNH2. If I want to know more about this one, MEF2D targets, I can simply click on it, and there are also links out to external resources. Again, if you're interested in having references to your own data that your company or organization has already collected, let us know. NExTNet has the flexibility to integrate your proprietary data with the larger body of knowledge in a private and secure way. But here we go. There are a lot more features for you to use, but this is a good glimpse into all of the power that NExTNet can put at your fingertips. If you're interested, again, we have an expanding documentation library on our website, and we will be continuously putting out demos as well as other informative materials on our YouTube channel. As always, here at NExTNet, our goal is to help supercharge your science. So feel free to reach out with any questions or suggestions. Thanks for watching.